Okay, this is unit 4.5. The bad news is that proofs are back. The good news is that this time around we have a lot more concrete information to prove triangles are congruent. So it's a lot easier than what we used in chapter 2 when we were talking about logic statements. So let's get right into it. On the first page of your packet is a reference sheet, and if you look at these are 5 very important theorems that uses the sides and the angles to define, to help you draw the conclusion that triangles are congruent or not. So first of all, it's SSS, which stands for side, side, side theorem. What that theorem says is that if I have 3 pairs of congruent sides, then I have one pair of congruent triangles. In other words, the 2 triangles are congruent. So what that means is that in this example, if these 2 sides are congruent, these 2 sides, the corresponding sides, are congruent, and then these 2 sides are congruent, then SSS would be sufficient enough to prove that these 2 triangles are congruent. Okay? For the same reason, SAS, which stands for side, angle, side, that's 2 sides and 1 included angles are congruent, then I'm good. What do I mean by included angle? And so first of all, that's 2 sides. This angle here is the included angle, and this angle here is included angle. So included angles are the angle sandwiched between the 2 pairs of congruent sides. So for example, this angle here would not count because it's not sandwiched between the 2 congruent sides, right? So third one, let me get rid of that. Third one is ASA, angle, side, angle, 2 angles and an included side. So 2 angles are congruent. If this angle and this angle are congruent, these 2, that one, are congruent. The included side, the side that sandwiched between the 2 congruent angles, are congruent. I have ASA, and that's enough to prove the 2 angles are congruent. Okay? Finally, AAS, angle, angle, side, meaning if I have one angle that's congruent, second pair of angles congruent, AA side, and this time this side and that side is congruent, but this one is not included. However, it's immediately adjacent to one of the congruent angles. So that what makes it congruent. Finally, HL, it's hypotenuse and leg. And notice that this only applies when you have a pair of right triangles, and which says if the hypotenuse, which is the longest side, as well as any one of the leg, and I'll just pick one. If these 2 are congruent, then I have a pair of congruent right triangles here. Okay, so there are 5 theorems. Notice that they're all about the angles and the sides, so it's just different combinations of it. The only combination of the 3 letters, angle and side, is that bad word I cannot say. When you have an angle and 2 sides that are congruent, and especially when that angle is not an included angle, when you have an ASS situation, that's a bad word that I can't say as a school teacher, and that's not sufficient to prove that 2 triangles are congruent. Again, we can't have bad word in geometry. And finally, these 2 parts, this reasons sides are congruent and the reasons that angles are congruent. These are just reviews. There's some really good notes here, so make sure that you review those. Finally, there's another theorem that we're going to use. It's called CPCTC. It sounds complicated, but it's actually really meaningful and easy to understand. It stands for corresponding parts of congruent triangles are congruent. So what does that mean? That means, first of all, I already have congruent triangles, right? So if, in this example, if triangle ABC is congruent to triangle DEF, then all of their corresponding parts are congruent. What are corresponding parts? This sides, this two sides, these two sides are congruent, and this angle are congruent, these two angles are congruent, and this pair is congruent. So whatever is in one triangle, you go to the same location in the second triangle, find exact parts, whether it's an angle or a side. That's what we call corresponding parts. So to be more specific, AB is congruent to DE, and AC is congruent to DF, and BC is congruent to EF. And angle A and angle D are congruent. Angle B and angle E are congruent, and angle C and angle F are congruent. All right, so that's all there is. And for the next 2 units, we actually just break them down and give you specific examples and practices and help you understand these theorems. But this is a really great summary of all the properties. So let's look at this. SSS and SAS. So let's see, what do we say here? If SSS states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So which means that in these 2 diagrams, if AB is congruent to DE because of these tick marks, and BC is congruent to EF, and AC is congruent to DF. Oops, that should be an F. Then we can draw the conclusion that ABC triangle is congruent to triangle DEF. So that's what side SS states. So how do we use this? For example, here, it's given PQ is congruent to ST. I highly recommend as you read, you just mark your diagram. QR is here, is congruent to RT. And R is the midpoint. If it's by midpoint, by definition of midpoint, these 2 segments should be congruent. And I'm asked to prove that these 2 triangles are congruent. So remember, any kind of 2-column proof, we always have to write down what's given first, right? So the first 3 information are given, and then we drew the conclusion PR is congruent to RS by definition of midpoint, because we went from step 3 to not midnight. I'm getting tired myself. Midpoint. And then from this step 4 to step 5, we can draw the conclusion that the 2 triangles are congruent, and that's based on SSS theorem. All right. Same thing with the second problem. We have JL is congruent to MN. So JL is here, MN is here, and K is the midpoint. If K is the midpoint, we can prove JK and KN are congruent. And then we're asked to prove these 2 triangles are congruent. So the first 2 points are given, problem. Then we drew the conclusion K is midpoint of Jn. So Jk is congruent to Kn. That's by definition of midpoint. And then, but don't forget there's also Lm. So K is also midpoint of Lm. So we draw the conclusion that Lk is congruent Kn, also by definition of midpoint. Finally, all three sides are congruent. The triangles are congruent. And that's based on SSS. All right, so finish number 3 and make sure that you pause the video. It's an easy practice, shouldn't be too bad, but you do have to fill in the statements on your own. And over here, you're going to, just a hint, over here, you're going to have to use reflexive property. Remember, reflexive property is the one that I call mirror property. Whatever you see in the mirror every day is whatever you are. So if angle A is congruent to angle A, that's reflexive. So in this specific case, it's AB is congruent to AB. That's by reflexive property. Everything else is pretty straightforward. So now let's look at SAS, side, angle, side. What that property says is that if two sides and the included angle of one triangle is congruent to the two sides and the included angle on the other side, then these two triangles are congruent. So in this case, we still have the same, oops, I'm sorry, keep messing up my paper here. So if I have AB and DE are congruent, and we have BC and EF are congruent. Oops, that's not that should be a bar. There we go. That's a wiggly thing. And the angle in between is angle B is congruent to angle E. Now we can draw the conclusion that triangle ABC is congruent to triangle DEF. And again, I want to remind you, make sure that the angles are all matched up. Right? They're corresponding angles. If you switch the orders, then these two triangles are not congruent anymore. So orders of the angles do matter. So let's look at an example here. We have JM, which is right here, is congruent to NL. We have JMN, which is this angle, is congruent to LNM, which is this angle here. Okay, and we're asked to prove the two triangles are congruent. So first condition is given, first statement. Second statement is also given. Thirdly, we need a third one. We either need another angle or we need a side. But notice that, I don't know why my paper keeps moving. Notice that if I have this line being congruent, if I can prove this one is congruent, that would be great. But obviously MN is congruent by to itself by reflexive property. And so now I have two triangles being congruent by SAS, right? Let's look at some other examples. Let me do make sure you do number 5. I will do number 6 with you. So number 6 says V is the midpoint. Oh, sorry about that. I touched something. It says V is the midpoint of WZ. So this part and this part are congruent, as well as XY. So this part and this part are congruent. So now we have to prove two triangles are congruent. First point is given. And second point, because of the midpoint definition, we can draw the conclusion that WV is congruent to VC by definition of midpoint. WVX is congruent to YVZ right here because they are vertical angles. That's by vertical angle definition of vertical angles. And XV is congruent to VY. That's also by definition of midpoint. Therefore, now I have a SAS theorem there to prove the two triangles are congruent. Again, notice that these these two angles are sandwiched between the two congruent sides. That's why we can use SAS. So let me see if I can move this upward. There we go. I can't. So let's look at number 7. It's a little bit more challenging. Number 7, I have HI is congruent to GJ. HI is also parallel to GJ. So let's write down what's given first, and I'm asked to prove the two triangles are congruent. So because these two lines are parallel, I can draw the conclusion that angle GJH, which is, use a different color, this angle, and angle IHJ, this angle here, are congruent. And that, if you recall, is by alternate interior angles theorem, right? And I also know that HI and HJ are congruent. HJ and HJ are congruent by reflexive property. So this line is congruent. And now I have two lines that are congruent with a sandwiched angle. That's SAS. By SAS, I can prove the two triangles are congruent. All right. So this is quite a bit of information. Make sure that you know how to do it. I recommend that you go through this video, then cover the problem and cover both the statements as well as the reasons. See if you can prove these reasons and prove these conclusions without any of the hints, and that will really help you learn. And we'll do more practices in school. All right, guys. See you in class. Bye.